The properties of an interface can be described in terms of surface stress, which represents the work needed to stretch an interface, and surface free energy, which represents the work needed to create a new interface. The relationship between these two quantities was derived in the 50 by Shuttleworth. We used molecular dynamics and statistical mechanics to check the consistency of the Shuttleworth equation. We calculated the surface stress by integrating the pressure profile inside the crystal and the surface free energy by using cleaving and thermodynamic integration, obtaining very good agreement between these two quantities. The relationship between surface stress and surface free energy stems from the fact that for solids, the surface free energy is a function of the strain, and in general, it depends from the direction of the strain, as can be observed in the top left and top right plot. The only case in which the surface free energy is independent from the direction is in the case of unstrained solid, as can be clearly observed in the bottom left plot for the case of zero temperature. By using these results, we can obtain the different components of the Shuttleworth equation that can be then compared with the surface stress obtaining from the pressure profile, which is shown in the bottom right plot. We then extended the cleaving methodology to calculate surface free energy for molecular organic crystal. We focused mainly on mannitol, and we considered different orientation, different experimental lattice parameters, and different version of the Gromov force field, united atoms and null atoms. We obtained qualitative agreement with experiments, but we also obtained significant difference for different force field and crystal structure considered. Here we can observe that the kind of the results that we obtain, that is to say the thermodynamic integration, the thermodynamic path, the integration of which gives the surface free energy, and as can be observed, they are all different for the same orientation by using different model and different experimental lattice parameters. In this table are summarized all the results that we obtained for different orientation, different model, and different experimental lattice parameters. We obtained very different values here, but we will also obtain the experimental observed behavior of the interfaces, with the lowest surface free energy for the 010, 120, and 011 orientation. Thanks for your attention.